This is the Math 227 Statistics. Today we learned the Chapter 7 Confidence Interval. We talk about the Chapter 7 notes. Here is the formula we are going to use. First one is a z-score for the also called standard score. Z equal population mean. X minus population mean over standard deviation, and the z-score for the central limit theorem, we need to divide it by square root of n, divided by square root of n. Then mean and the standard deviation for the binomial distribution, mu, mean, population mean is equal n times p. And p is a probability. And the standard deviation is the square root of variance. Variance is NPQ. Take square root is the standard deviation. And this is a confidence interval, is a sample mean plus minus z-score times standard deviation over square root of n. If standard deviation sigma is given, and use z. And the sample size for the mean, for the population mean, n sample size equal z times standard deviation divided by margin error. E is margin of error, and take a square. Then confidence interval, if the mean is unknown, if the mean is known, use z-score. If the mean is unknown, use t-score. T-score as the sample mean minus t, and the sample standard deviation over square root of n. The other side is plus. Confidence interval for proportion, it's use z-score. And p hat is a sample proportion minus z-score and times square root of p hat q hat over n. This is standard deviation. Standard deviation of the proportion is a p hat q hat over n, take a square root. And what is a p hat? P hat is x over total n. What is a q hat? Q hat is 1 minus p hat. And the sample size for proportion is a p hat times q hat, and the z-score over margin error squared. Confidence interval for variance, sigma square is the population variance, is equal n minus 1. Degree of freedom is n minus 1 times variance of sample. Sample variance is s squared over chi square right. The other side is less than degree of freedom times sample variance s squared over chi square left. And the confidence interval for standard deviation is just take square root. This sigma square take square root is sigma. This left side take square root, then right side take square root is standard deviation. Those are formula we are going to cover in this chapter 7. Chapter 7, the topic is confidence interval. And the first question on the notes. The first question say an interval estimate may or may not contain the true value of the parameter for the proportion, we call parameter. Parameter including like a mean, like a variance, like a standard deviation, like a proportion. For population, we call parameter. And being estimate, circle your answer, yes, true or false. So may or may contain, probably contain interval. The interval, confidence interval may contain or may not contain. true, is true. Second question, in a recent study, 35, 9 greater, so n equal 35. Here, n equal 35, 9 greater students, and the mean number of hours per week that they play video games was 16.6. So this is a sample mean, so use X bar. Given it's 16.6 hours play the video game. Average for 35 students, average is 16.6 hours play the game. The standard deviation of the population sigma is given. So this time we will use z-score, is 2.8. A, find the best point estimate of the population mean. So the best point estimate of the population mean is a sample mean. Sample mean. Sample mean here given X bar is 16.6 hours. It is the best point estimate of the population mean. B, and find 95% confidence interval. So this time is 95% confidence interval of the mean, population mean, mu, of the time playing video games. So this population mean confidence interval is between what two number, what 2 hours. So that means this is a normal distribution, symmetric, and bell shaped and symmetric. And then between them is between what's two number, and this is z-score, and between interval, confidence interval is 95%, and we need to find out the z, alpha over 2. This side alpha, alpha is 1 minus 0.95, which is 0.05. So alpha over 2 is 0.05 divided by 2 is 0.025. So this side is alpha over 2. And between it, this one is alpha, 1 minus alpha, and this side is alpha over 2. This side is alpha over 2. 95% confidence. So this side, alpha over 2, alpha, which is, this is a negative z, alpha over 2, this area, alpha over 2, and this area is also z, alpha over 2. So figure out the 2 number. Now, how to figure out the 2 z-score? You look at the table, look at the T table, 95% confidence. Confidence interval, 95%. Use this z-score. T distribution. Go to the bottom. Bottom. This row, the bottom row is for z-score. And 95% confidence, 95% confidence interval. Go down to the bottom, this number, which is z. Z-score is 1.96. So left side is negative 1.96. The right side is positive 1.96. Then plug into this confidence interval for the mean, population mean, will be between X bar 16.6, which is the sample mean, minus z-score is 1.96. And the standard deviation, population standard deviation 2.8 divided by square root of 35. And the other side change to plus. and use calculator figure out and round it. The answer is 15 point rounded to 2 decimal digits. So it's 15 population mean. Use this sample to estimate the whole population average hour to play the video games for the 9th grader students. From this sample, we can say there are 95% confidence the population average play the game is 15.67 hours, between 15.67 hours and 17.53 hours. And this we call confidence interval with 95% confidence. And question 3 is also find the confidence interval and use same formula. So because this question given, those are given condition. And the average number of mosquito caught in 81 mosquito traps. So n sample size, n equal 81, and figure out the average in a particular environment was 900 per trap. Each trap average is 900 mosquitoes. This is a sample mean, x bar equal 900. The standard deviation of mosquito caught in the entire population, so it's a sigma, standard deviation population, entire population of traps is 100 mosquitoes. And those are given condition. Ask you 95% confidence, 95% confidence interval for the true mean, which is mu, number of mosquito caught in all mosquito traps. The true average is falling between what two number? That's confidence interval. So you plug into this also. The population standard deviation is given. So we will use z-score. Use z-score. So then use same formula. Mean, sample mean is 900, plug in, minus 95% confidence is the same as the previous question. 95% confidence. One is net 1.96 and the right side is 1.90, positive 1.96. So it's minus 1.96 and 100 standard deviation over square root of n is 81. The other side is plus. Then use calculator figure out. And confidence interval for the true population average mean for the number of mosquitoes caught in all mosquito traps for all populations. Average confidence with 95% confidence will be interval will be between 878.22 mosquitoes and 921.78 mosquitoes per trap. That's true population average mean as per trap will be falling between 878.22 mosquitoes per trap and 921.78 mosquitoes per trap. And question 4, a healthcare professional wishes to estimate the birth weights of infants and how large a sample. So that's looking for n sample size must be obtained, looking for n obtained if she desired to be 90% confidence, 90% confident that the true mean is within 2 ounces. So margin error E is 2 ounces, of the sample mean. So true mean, which is the population mean, which is mu, true mean, and the sample mean is x bar. That difference is we call within two errors. This is we call margin error. The true mean, which is the population mean, is within 2 ounces of the sample mean. Sample mean is x bar, and the difference would need to be within 2 ounces. So this margin error actually is the difference between sample mean and the true population mean. We call margin error. That's given here. E is 2 ounces, within 2 ounces. And assume that the population standard deviation is 8 ounces. So sigma is 8 ounces. So use this sample mean, the mean sample size for the mean formula. The formula is z times population standard deviation sigma over margin error e and squared. So here, so first of all, this question is a 90% confidence. So that means between it is 90%, 0.9 is the same as 0.90. So this between it is 90%. And 100 minus 90%, got 10% divided by 2. So this side is 5%. And right side tail, left tail 5% is 0.05. Right tail also 0.05, 5%. So confidence interval is 90%. You use the t-distribution looking for 90%, also looking for z-score. So you go down to the bottom of t-distribution table and go down, and this the bottom row is for z, z-score is 1.645, and so this z-score, this side is 1.645, the other side is negative 1.645, so this z-score is 1.645, and times by standard deviation given is 8, population standard deviation is 8, over margin error is 2. And then figure out, then square it. You got 43.2964. Always round up. Even here is 2. Still round up. Got 44. Always round up. So the n sample size should be 44. Has to survey 44 infants and get the 44 birth weights. And then you will have 90% confidence that the true mean is within 2 ounces of the sample mean. The sample size to survey need to be survey 44 infants, their birth weights, then you can have a 90% confidence that the true mean is within 2 ounces of the sample mean. That's question 5. A sample of 10. So those are given. This given sample size n is 10. Networking sites for specific month has a mean 26.1. So sample mean is 26.1. And the standard deviation, sample standard deviation S is 4.2. Find the 99% confidence interval. So this is a 99%, looking for 99% confidence interval. So we use the confidence interval with the t-distribution since population standard deviation is unknown, is not given. But sample standard deviation S is given, is known, which is 4.2. Here is the sample standard deviation is 4.2. We need to use t-distribution to do. For t-distribution, first of all, we have to figure out degree of freedom because this t-table, t-distribution table, this side is degree freedom, degree freedom. So degree freedom is n minus 1 is degree freedom, and here n is 10. 10 minus 1, n is 10. 10 minus 1 is 9. Degree of freedom is 9. Then we're looking for t value. How to look at t value? You look at here, say 99% confidence. This one, 99%. Confidence interval, 99%. Degree of freedom is 9. This one, 9. Their intersection, this one, 3.25. 3.25. So we got is t it's 3.25, and plug into this and this. Plug in. So we got this is a formula, confidence interval formula. So the x sample mean 26.1 minus t is 3.25 times sample standard deviation s is 4.2 over square root of n is 10, less than population mean, less than the other side is changed to plus. And use calculator, you are able to figure out it is between this, between 21.78 and 30.42. Then question 6. Question 6. It's a survey of 1,500 adults. So given n equal 1,500, found that 39%, 39 is the sample proportion, p hat is the sample proportion is equal 39, is 0.39. Said that they would take more. You survey for 1,500 adults. You got there are 39% of 1,500 adults. So this we call proportion. P hat is 0.39. Is a sample. We put p hat is for the sample proportion. Said that they would take more vacation this year than last year, and find the 95% confidence interval. So looking for 95% confidence interval of the true proportion with p. Looking for this p, true proportion. This is a population proportion, is a p. And p hat is for sample proportion of adults who said that they would travel more this year. So this, we are going to use this proportion confidence interval formula is a p hat minus z score, and times standard deviation for proportion is the square root of p hat q hat over n. Take square root. So in this formula, we have p hat and q hat. What is the q hat? Q hat is 1 minus p hat, is 1 minus 0.39, and get 0.61. Then plug into this formula. P hat is 0.39, plug in, minus z score. Now here z score is a 95% confidence interval. Again, let's do again. A 95% confidence interval, find the z score. Go to the bottom. Here z score is 1.96. So it's a 1.96 minus 1.96 square root of p hat. P hat is 0.39 and q hat is 0.61 over n is 1500. And the other side just changed to plus. and use calculator, you are able to figure out the proportion. There are 95% confidence that the population proportion, the true proportion, will be falling between 36.5% and 41.5% of the adults would take more vacation this year than last year. So, then next question, question 7. It is believed that 25%, so P hat is 0.25 of U.S. homes have a direct satellite television receiver, and how large of a sample is. So how large a sample? So looking for N, how N is the sample size. It's necessary to estimate the true proportion, which is population proportion, of homes which have a direct satellite with 90% confidence, with 95% confidence within 3 percentage points. Margin error is 3%. 3 percentage change to decimal is 0.03. So it's within 3%, which is 0.03. This number is a difference between sample proportion and the true population proportion. We need to be within margin of error. Margin of error is the difference between sample proportion and the true proportion. And this need to be within, here given 3 percentage. So margin error, it's 0.03. So in this formula, it's a sample size formula. It's a P hat times Q hat times z-score over margin error square. So P hat is 0.25. Plug in. Q hat is 1 minus P hat is 1 minus 0.25. It gets 0.75. So Q hat is 0.75. Plug in. And here's a 95% confidence. We already know, use this many times. 95% confidence, z-score is 1.96. Divided by margin error, E is 0.03, and square it. And get 100.33. And always round up. Even here is not greater than 5. Still round up. Even 3 is still round up. Get 801. So need to survey the sample size. Need to be 801 homes. Survey 801 homes. Then you can get 95% confidence. Your survey 25% is within 3% of the true proportion. That means your survey 801 homes, and you got 85% of the home have direct satellite television receiver. This 25% is 90. There are 95% confidence that 25% of the whole of the homes have the direct satellite TV is within 3 percentage of the true proportion of the homes. the true population, true proportion of the homes, compare with you survey 801 homes, get the answer is 25%. This 25% compared with true proportion is within error. Error is 3%. 3%, within 3%. So that means at 3% is 28%. Below 3% is 22%. So this 25% you got by the sample. This 25% to the true proportion is within error is 3%. Within the error. Question 8. And find the 95% confidence interval for the variance of the heights of a maple trees if a sample. So, and looking for a 95% confidence interval for the variance. Variance is a sigma square. Population variance is a sigma square. And there's the sunlight. So find the 95% confidence interval for the variance is a sigma square of the heights of the maple tree. How many feet? If a sample of 16 trees, so this given n equals 16 trees, has a standard deviation. So this is a sample, 16 trees. Get a standard deviation. S is a sample standard deviation is 12.2 feet. Assume the population is normal distributed. So this is, you figure out this variance. Find confidence interval for variance. So use this confidence interval for variance. This confidence interval for variance formula. And this is n minus 1 is degree of freedom. N is 16 minus 1 is 15 times S square. S is 12.2, 12.2 square. And we need to figure out chi-square right, and the chi-square left, the two value, and plug it in here. Now how to figure out chi-square? For here, say 95% confidence. That means between this area is 95% confidence. And figure out this confidence, chi-square left, chi-square right value, and plug it in here, chi-square right and chi-square left. Now, according to the chi-square table, this is this. In order to get this chi-square, you have to use this area to the right of chi-square. Because on here, like 0.005 is this area to the right, and then you can figure out corresponding chi-square values. On the body is chi-square values. I'll show you. Now, this is a 0.95, and then you divide it by 0.05. 1 minus 0.95. And you got is 0.05, and divided by 2 is 0.025. So this side, the right tail is 0.025. Left tail also, this also 0.025. And you will use this area. Use this 0.025 area. And figure out chi-square right. 0.025. So look at 0.025. Degree of freedom is 16 minus 1. For this question is 15. So here, 15. 15. Intersection. Degree of freedom and 0.025 intersection this 27.488. This area, this area is on the top 0.025, and degree of freedom is 16 minus 1 is 15. Intersection is 27.488. That's this chi-square. 27.488. So this number, chi-square, this area is 0.025. This number figure out is 27.488. Now we need to figure out chi-square left. Also, you need to figure out to the right of this number. And here, this area is a 0.95. Add this area, 0.025. So to the right of this chi-square number, total is 0.975. 0.95 and 0.025 add together is 0.975. So to the right is the entire area is 0.975. Now you look at the table. 0.975 is to the right area, corresponding chi-square. Degree of freedom is 15. Chi-square is 6.262. So chi-square left side is 6.262. Then you plug it into the formula. Chi-square right is 27.488. Chi-square left use 6.262. Plug it in. N minus 1 is 16 minus 1. S is 12.2 square. And use calculator, you figure out variance sigma square is between 81.22, rounded to 2 decimal digits, and 356.53. Next question. A chi-square variable cannot be negative. That's right. Cannot be negative. Started at 0. Chi-square variable started at 0 cannot be negative. To the right of 0 is 0 or positive. Cannot be negative. That's correct. And the distribution are positively skewed. And this side is a fatter, higher fat. This side is a slim. So this side is a positive side and the left side is a negative side. So it's a skew to the right is a positively skewed. So it is true. It is true.